Before I'll start my formal discussion, let me define first what is a polygon.
What is a polygons? A polygon is a closed plane figure made up of several line segments that are joined together. Exactly, two sides meet at every vertex. Parts of polygons. We have the side. It means that one of the line segments that make up the polygon. We have the vertex. It means that point where two sides meet. Two or more of these points are called vertices. Diagonal, a line connecting two vertices that is not a side. Interior angle, angle that form by two adjacent sides inside the polygon. We have the exterior angle, angle formed by two adjacent sides outside the polygon.
So this is an example of a polygon. We label this as A, B, C, D, E. We name this polygon as polygon A, B, C, D, E, or polygon E, D, C, B, A. So we are going to find the sides of this polygon. So the sides of this polygon are line segment AB, which is this one, line segment BC, line segment CD, line segment DE, and line segment EA. And the next one is we're going to find the angles of this polygon. So the angles of this polygon is angle A, angle B, angle C, angle D, and angle A. Angle A, angle B, angle C, angle D, and angle E. So the third one is we're going to find the vertices of this example of a polygon. So the vertices of this polygon are point A, point B, point C, point B, and point E. So the last one is we're going to find
Natago ka.
So the next one is we're going to find the vertices of this sample polygon. So the vertices of this polygon are point A, point B, point C, point D, and point E. So the last one is we're going to find the diagonals of this polygon. So the diagonals of this polygon is RDI.
Bahala na lang.
So the last one is we're going to find the diagonals of this polygon. So the diagonals of this polygon are diagonal AC, which is line segment EC, line segment BE, line segment AD, and line segment ED. So these are the diagonals of this polygon.
The polygons formulas. N is equal to the number of sides. N minus 3 is equal to the number of diagonals from one vertex. N minus 2 is equal to the number of triangles formed. the quantity n minus 2 times 180 is equal to the sum of the measures of the angles formed. N times the quantity n minus 3 all over 2 is equal to the total number of diagonals.
These are the types of polygons. We have the quadrilateral, the pentagon, the hexagon, the heptagon, and the octagon or the n-gon. In getting the number of sides, we have this formula. N is equal to the number of sides. So, we have, in quadrilateral, we have 4 sides. In pentagon, we have 5 sides. In hexagon, we have 6 sides. And in heptagon, we have 7 sides. And in octagon, we have 8 sides. So, in getting the number of diagonals from one vertex, we have this formula, n minus 3. So, n is equal to the number of sides. So, 4 minus 3 is equal to 1. So, 5 minus 3 is equal to 2. So, 6 minus 3 is equal to 3. So, 7 minus 3 is equal to 4. 8 minus 3 is equal to 5. So, in getting the number of triangles formed, we have this formula, n minus 2. So, 4 minus 2 is equal to 2. So, 5 minus 2 is equal to 3. 6 minus 2 is equal to 4. And 7 minus 2 is equal to 5. And 8 minus 2 is equal to 6. In getting the sum of the measures of the angles formed, we have this formula. The quantity n minus 2 times 180. So, 2 times 180 is equal to 360. 3 times 180 is equal to 540. 4 times 180 is equal to 720. 5 times 180 is equal to the 900. 6 times 180 is equal to 1080. To understand further the basic properties of polygons, study the following examples. So we have example number 2. Find the sum of the measures of the angles of a convex dodecagon. Solution. We all know that a dodecagon has 12 sides. Therefore, n is equal to 12. So, in finding the sum of the measures of the angles of a convex dodecagon, we have the formula, the quantity n minus 2 times 180. Substitute n is equal to 12 to the formula. So we have 12 minus 2 times 180. So 12 minus 2 is 10. So 10 times 180 is equal to 1,800. Since we've done discussing, I hope you learned something.